Okay, this is going to be a strictly for a walkthrough on the JB-76, especially concerning the bias. I got a, I wouldn't call him a customer, but I got a guy, looking to repair his JB-76, and he says he has no bias at the tubes. One of the problems is they made about 15 versions of the JB-76, aka JB-200, different voltages, different routing, different colors of the wiring, different pinouts, and all that. But I did pull out mine, which is one of mine, which is one of the more common ones. This one is and then it's been modded to heck, so not a great example, but hey, it works, and it's enough to do the demo on it, which I'm trying to do of the JB-76, especially concerning the bias. One of the problems is, one of the main things they changed is that early versions, they use a two-stage bias, where they would run high bias when the amp is in standby. You've heard me talk about bias on the Palomar 300As, and they'd go up in smoke if the bias wasn't right, because they had the voltage on them all the time. Well, Blackcats pretty much don't go up in smoke. They got a pretty good circuit breaker. They're not over fused, at least the JB-76. So normally if it has a problem, it'll blow the circuit breaker. They tried to make it kind of foolproof as much as they could, but on the earlier ones they use a two-stage bias. They use somewhere around 60-70 volts of negative bias during standby, which is enough to cut off the tubes. The tubes, got the high voltage on them, but with all that negative bias, they're happy. They're not conducting. They're not on. They're not pulling power. And and when you key down, it took the bias to the second stage, which is the lower voltage, somewhere around, I've seen everything from 28 to 40, depending on the tubes. This one with 7581s, it took the bias down to 30. Well, this is a single bias, but the bias was 32 volts. One of the crazy things about Blackcats, they purposely made their schematics very confusing, right? You see that zener there? Actually, that's the bias power supply. Goes through the diode, the cap. Then there's a zener which regulates it or sucks it down from the 64 to the 32 volts. And that's going to be a 32 volt 2-watt zener. I actually replaced that with 5 watts when I do it, or actually it says 1 watt, I think. Anyway, like I say, Blackcats are confusing, but anyway, the zener takes it to 32, but up here they say it's 64 volts again. Now, which one really is it? It's actually 32 on this one, should be, but again, Blackcat, I think a lot of that they did on purpose to keep people from copying their design. And if you see the dotted lines going across there, and it goes to that relay contact there, that's what the dotted line is indicating, that that's a relay, and all that. The relay on the input side contact, on the output side contact, and the third contact there, that's the screen. On this later version, they turn the screen, or the turbocharge I call it, on and off to make the tubes not conduct. So it opens the screen voltage, so no screen voltage on the tubes when you're not keyed. Then you key down that third leg of the relay, applies that 400 volts on this one to the screen, and keys it down, and the tubes are in operate mode. So anyway, this one is the single bias, which is the most common, and that bias is on there all the time, and it's steady on this one. So anyway, to get to it, for the bias, at least on this one, they had, like I say, 15 different versions that I know of, probably more. But it has a separate transformer winding on this one for the negative bias, and it's blue wire. BL is blue, coming out of the transformer. One of the wires goes straight to ground, and the other wire goes straight to a power supply type diode, a common 1N 4005 or 4007 diode. Okay, on this actual power supply of a JB-76, it's hard to see with the camera and the lighting and all that, but that ugly soldering, that wire there, is actually blue. It looks kind of greenish, kind of like a greenish blue. Actually, it's the blue underneath, the green on top, and then the bluish green underneath. That's the one going to ground right there. And so the green one is the filament too, and it goes to ground. And then the other leg of that bias coming out the transformer, and that's some ugly soldering, you're looking up close up, right? Goes to that diode I was talking about on the schematic. And that diode regulates that AC coming in, because you get an AC out of a transformer, half wave, and then it the diode is configured so only the negative portion of it will go across that diode. It's like a one-way valve. So on that side of the diode, to the left, you will have negative pulsing AC. Well, it's not AC, but you have negative voltage on it. Then it goes through this resistor right here, and on the schematic, that resistor is that 3.3K resistor. So if you got it unpowered, unplugged, not charged up, you can measure that resistor. And remember, they use many different versions. You know, it might be 4.7K, 6K, 2K, you know, very different versions of this thing. But if you got no power, you can measure that resistor there unpowered, and it should be around 3.3K. Also connected to that diode is that capacitor there, with positive going to ground and then negative connected to that resistor too. And it's hard to see. You got the diode, the resistor, and then that leg at the top, and then the capacitor is back there, kind of tucked in, you know, back there. That's the capacitor there that turns that negative AC into negative DC, right? It filters that AC out. So on the other side, on both sides of that resistor, you should have about well, on the right side you should have about 60 volts. And then on the left side, normally there's a zener diode that regulates it, that knocks that voltage down. Some very early versions use resistors. They didn't even use zeners. Like I say, many different versions of this thing. But that's a zener, that 32 volt, when it knocks it down to 32 volts. So on the left side of this one, I should have about 32 volts of bias. And then from the left side, it actually goes out the power supply deck to the RF deck. And here it goes through this green wire here, out the cord and over to the RF deck. And it goes to the RF deck on this one. The negative bias, that 32 volts negative, goes to pin 5 on the socket there. And then here's a very common problem with this one. It goes out of pin 5, which is that brown one at top, over to this choke here, that little small choke there. And a lot of problems is that choke will open, and that will make you lose the bias when that choke opens. If you put your meter across that choke unpowered and on ohms, it should be very close to a dead short, like, you know, maybe 2 ohms or something like that on that choke. If it's not reading a very low ohmage, then that choke is open and needs to be replaced. A very common problem is that choke shorts, or the zener diode shorts. Another problem with these amps is they put the components all over the place, and they put the zener diode all over the place. I've seen decks with the zener on this side in the RF deck. Over on the right side of the choke, then I've seen decks that have the zener in the power supply connected to the resistor there, and then I've seen others where that whole negative bias assembly is actually over in this corner here. Don't worry about that. That's some adjustable variable bias I was playing with, just experimenting with. But I've seen that whole thing, you know, over here in this corner. So, you know, it's no guarantee where that's going to be. But look for that, you know, power resistor and that diode and the blue wires. Look for that blue wire. One of them's going to go to ground. Don't worry about that one. But wherever that other blue wire go, going to be connected to a diode, then a resistor. And that capacitor is kind of hidden up under the circuit breaker. You can see the side coming out, you know, going to ground. And that'll be your negative bias coming out the power supply. And then over in the RF deck again, a big problem is the choke opens. And over in this side, wherever the zener is, the zener shorts out your negative voltage. So if you got no negative voltage coming out the power supply, I would check for a short with the zener. You can always look for wiring, maybe an open resistor, but the more common problem is a short on the zener, wherever it is. It's in different places. Well, on this one, I got lots of zeners on that switch there, so I can switch the bias around. But anyway, that's experimental. But wherever your zener is, it may short and kill the bias. And then coming into the deck, if you got it, coming out of pin 5 into that choke there, if you got it, check the other side of that choke. You can check that choke for resistance, unpowered, or you can power it up and see if you got the negative bias on the right side. And if you do, check your left side to see if you still got it. Then it goes from there into your input tuner or input transformer or input choke, whatever you want to call it, through that brown wire there on the right, as we're looking at the picture or the camera. And then it comes out the top to those two brown wires here and into the tubes through those brown wires into pin 5 of the tubes. So if you got it coming out the choke, it goes into your input transformer and then out the transformer. So if you got it going in and not coming out, then your input tuner is bad. Got to open somewhere. Might have a broken wire. I've seen that all the time. You know, people keep screwing and playing with that input tuner and they start breaking the wires off and stuff. So seen that. But it's not that hard to trace if you know what you're doing. Actually, I had this hooked up. Don't know if it's still good. I was going to do some tracing if it's still working. Let's see. Yep. Okay, I just got a DC power supply hooked here to my bias. And I'm checking it where it would come out of the diode. And I got negative 15 volts there. And then across that power resistor is my second check. And I got negative 15 volt there. And then that's where it goes out this green wire here through the cable and the plug. Sometimes you lose it there. You got a bad connection at the socket and the plug. But I'm going to check the output of that wire there where it comes out before it goes into the choke, or as it goes into that choke I was talking about. I got negative 15 there. And then I'm going to go to the other side of that choke. And I got negative 15 there. And then I'm going to go into the input tuner over here. Got negative 15 there. And then I'm going to come out of the input tuner over here. Got negative 15 there. And then out there into the tube, pin 5. Come on, get on there. Trying to get a good contact. Here we go, negative 15 there. And you can do the same thing with the ohm meter. Connect one end to where the diode is, and just keep going across. You know, you're going to get about 3.3K there, and then, you know, from everywhere else, it should be a dead short. You can do that unpowered. If you do this thing powered up with it plugged in and you're checking for your 32, you know, volts and 64, be very careful. As a kid, I almost killed myself with a little JB-150 playing with it without knowing what I was doing. But I had a mic in one hand and had a key down, and this is unplugged, unpowered, but I was kind of feeling around because it was getting hot in this area. And that's when I saw Mr. Arc, and I thought somebody came in and hit me in the head and bashed my head in with a baseball bat, is what it felt like. And I was out for a couple hours. When I woke up, I couldn't open one of my hands, and that was my my only real big shock that I've ever had in my life. And it's like, after that, I was going to learn this stuff. Anyway, good luck with this. CB Tricks has the schematic, and you can, you know, look yours up, but most of them look like that. Here's an older version with the 2 biases, and you can see this one of them comes in at 120. That cutoff bias comes on pin 2, the negative 36 on pin 4. That one's 2, but most of them don't use that. And then it goes through the switch there to switch the bias, and this one switches the bias instead of the screen. Anyway, this ended up being a lot longer than I wanted to, but again, it was just to try to help somebody out. But I tell you, it's easy for me to fix an amp, but it's not easy to try to troubleshoot when you don't know what's going on and you can't see it for yourself. All right, that's it for this. Bye.